My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 581. In this lecture, I will continue my discussion on Softmax Classifier. Before understanding this lecture, I request you to go through my previous lecture, that is lecture number 580. This particular slide is from my previous lecture. Try to recall, we were discussing that sigma 1 z1 equal to e power z1 by sigma I equal to 1 to k e power zi. In similar manner, sigma 2 z2 equal to e power z2 by sigma I equal to 1 to k e power zi. So literally what we are doing here, you take all the inputs x1, x2, x3, so on xn. The bias term is like b. Here b is bias term because you can write it as w transpose x plus b. So this is your x. What is my x? X is x1, x2, so on xn. If you look at each of these, z1, what is this one here? zj equal to wj transpose x. Here what is my z1? Just if you substitute here, what I have to substitute, just see, let me write this one. This is zj. If I keep j equal to 1, my z1 equal to w1. I am keeping j equal to 1, w1 transpose x. In similar manner, what is z2? If j equal to 2, I am keeping here z2 equal to w2 transpose x, isn't it? Here I have z1, here I have z2, here I have z3, here I have zk. In similar manner, what is my zk? Zk is wk whole transpose dot x, isn't it? These are z1, z2, so on, I can say zk. What it is computing, zj equal to wj transpose x. Literally, it's computing literally wj transpose x. In the Softmax classifier, basically returns the output. All the outputs of these sigmas is sum to 1, isn't it? Just see what is all the output summation. That output is, what is first output? What is the sigma 1 z1, that is e power z1 by summation I equal to 1 to k e power za. Sigma 2 z2, that is e power z2 by summation I equal to 1 to k e power zi, so on sigma k zk e power zk by summation I equal to 1 to k e power za, isn't it? In the Softmax classifier, because it returns all the outputs of these sigmas is sum to 1. Let's verify this, isn't it? What is your just let me verify whether sum equal to 1 or not. Just see, what is your sigma 1 z1 e power z1 by sigma. Just see, it is simple and straightforward. This one we would like to understand. Sigma 1 z1 plus sigma 2 z2 plus 1 sigma k zk. Sigma 1 z1 means this part, sigma 2 z2 means this part, sigma k zk means this part. All denominators are same. Just I am taking LCM. If you take LCM, what will you get here? Your numerator and denominator are same. They will get cancelled. You will get 1, isn't it? So what's happening here? Just understand. This one is sigma. What is the input for sigma 1? z1. What is the input for sigma 2? z2. What is the input for sigma 3? z3. What is input for sigma 4? Let me say z4, isn't it? What is the output of sigma 1 z1 means probability of y equal to 1 given xi, isn't it? So in a nutshell, Softmax is basically generalization of logistic regression to a multi-class setting, isn't it? Just see here, I have sigma 1 z1, sigma 2 z2, sigma 3 z3, so on sigma 4 z4. As the sigma 1 z1 value is, I can say probability of y equal to 1 given xi. Sigma 2z2 means probability of I equal to given xi. Probability sigma 3z3 means probability of I equal to 3 given xi. In similar manner, sigma 4z4, that is probability of yi equal to 4 for given xi. In a nutshell, I can say softmax is basically a generalization of logistic regression to a multi-class setting without using one versus rest. The most important thing here is in logistic regression, what do we have? In logistic regression, sigma z equal to 1 by 1 plus e power minus z, isn't it? Which is equal to e power z by e power z plus 1. In the case of softmax, what is my sigma 1 z1? E power z1 by summation I equal to 1 to k. E power z is sigma 2 z2 means e power z2 by summation I equal to 1 to k, e power z so on, sigma k z k is e power z k by summation I equal to 1 to k, e power z a, isn't it? Logistic regression minimizes your log loss. Softmax minimizes your multi-class log loss, isn't it? Yes. So let's look at multi-class log loss. What is multi-class log loss? There is simple article. Just go through this article. What it says in the case, what is multi-class log loss? Multi-class log loss can be defined as follows. Yes, we will try to understand what is multi-class log loss. In this case, suppose you have n points. Let me assume I have n points, I equal to 1 to n. Let's say k classes. Let me change my m to k. So you have capital N points and you have capital K classes. So multi-class log loss, which is also called as cross entropy in some cases. This is average value, isn't it? This is basically summing up. Just understand the definition. What is Yij? What is the meaning of Yij? Yij basically means it is a binary indicator. Yij equal to 1. Yij equal to 1. If the point yi belongs to class J, otherwise it is 0. It's a binary value. Pij, what is my Pij? Basically probability that yi belongs to class J given xi. That is probability of yi belongs to class J, isn't it? Class J given xi. So you are multiplying a binary vector with the log probabilities, isn't it? Here what's happening? You are multiplying just this one. Which one is? This one is actually log of Pij. It's not log comma, it's a printing mistake actually. It's log of Pi here. It's not comma actually, isn't it? Yij into log of Pij. Yij is binary indicator, binary and log of Pij. Pij is the probability of yi belongs to J given xi, log probability, isn't it? And if k equal to 2, then it will be 2 class log loss, isn't it? What is 2 class log loss? Minus of 1 by n sigma I equal to 1 to n yi log Pi. This one is not log, this one is log Pi. This is basically, what is this? 2 class log loss. This is 2 class log loss. That's what it says, isn't it? Anyway, we'll try to understand what is yi, where yi is basically 1. Yi is basically 1. If it is belongs to class 1, 0 otherwise. What is my Pi? Pi is basically P of yi equal to 1 given xi. This is 2 class, I can say this is 2 class log loss, and this one is multi-class log loss. In this slide you have 2 class log loss as well as multi-class log loss. Multi-class log loss have nice properties. Let's assume there is a point xi. Let me assume there is a point xi for which yi equal to 3. Let's assume I have k classes. So what is my yij in the what is my yij in the formula? It is equal to 1. It is equal to 1 for j equal to 3. Rest of everything is 0, isn't it? Let me assume here only for yij, for j equal to 3 only I have one value, isn't it? Let's assume you input point xi into model m like a softmax classifier. It will return bunch of probabilities. P of yi equal to 1 given xi, P of yi equal to given xi, P of yi equal to 3 given xi. So what are we doing here? Minus 1 by n. What is our formula? This is our formula for multi-class 1. This one is formula, isn't it? Sigma minus 1 by capital N, sigma I equal to 1 to n, sigma j equal to 1 to k, yij into log pij. We are taking the yij. What is yij? Yij is just try to understand yij. We are taking yij. Yij is 0 for everything except the true class, isn't it? For everything it is 0 except the true class. Except the true class, everything is 0, isn't it? 0 multiplied with anything is 0. We only care about the probability of the true class. So for a data point like xi, yi equal 3, for this particular data point, when you actually compute sigma j equal to 1 to k, yij into log pij, what happens? It is summation over all the classes. Sigma j equal to 1 to k means what? It is summation over all the classes. Here we have how many classes? We have k classes. Yij is 1, isn't it? Yij is 1 for only class 3. That is important. Everything is 0. The probability it belongs to class 3. The probability it belongs to class 3 is 0.7. Just see this probability P of yi equal to 3. What's happening here? Just if you write also j equal to 1. If you say j equal to 1 means what? This is yi 1 log pi. Pij means 1 log pi 1 plus yi2 log pi 2 yi3 log pi3. Anyway, what is yi3 value? yi3's value is 1. Therefore 1 into log pi3. pi3 means what? This is pi3, that is 0.7, isn't it? Therefore 1 into log of 0.7, isn't it? That's what you will get. 1 into log 0.7 is what is left for this point x. For this point xi, there is only 1 into log 0.7. Rest everything becomes 0 because yij for this point is 0. This is called multi-class log loss and softmax. What is this? This is known as multi-class log loss, and softmax minimizes multi-class log loss, just like logistic regression, isn't it? This is 1 into log points. Yes, what it says, softmax minimizes multi-class log loss, just like logistic regression minimizes 2-class log loss and 2-class log loss, and softmax something like we use extensively in all multi-class problems. For example, let's assume we have a multi-layer perceptron. We have input layer. Let me assume I have input layer and I have layer 1. This is my input xi. I have my layer 2. L2 is layer 2. If my problem is 2-class, let me assume this is 2-class classification problem. The output layer is a sigmoid layer. Here sigmoid layer is a output layer, generates my yi cap, which generates yi cap here. I have my xi, isn't it? Because it is a 2-class classification, isn't it? Because it is a 2-class classification. On the other hand, what I have is k-class classification, isn't it? The architecture looks like this. This is for k-class classification. I have my input xi my layer 1 here, my layer 2 is here. In the last layer, instead of sigma, I basically have softmax layer, isn't it? I basically have softmax layer. We generate string of probabilities. It generates a vector of, I can say, size k. How many probabilities it is generating? It is generating k probabilities. Therefore, I can say it is generating a vector of size k. Imagine if it's regression problem, what happens? Instead of sigmoid, what will you do here? I will give output whatever I get. I can just make it like a linear unit. What is my linear unit? F of z equal to z. Here, instead of sigmoid, this sigmoid will be replaced. This particular, if it is regression problem, the sigma will be replaced by linear unit. What is linear unit? Linear unit is f of z equal to z, isn't it? In the case of regression, you can use simple linear unit. In the case of regression, we can use what you can use? Simple squared loss. In the case of two-class classification, I can use two-class log loss. In the case of k-class, in the case of two-class classification, I can use log loss. In the case of k-class classification, I can use multi-class log loss. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.